So this class we shall discuss Michelsons Interferometer, which is another instrument which is based on fringe formation, interference fringe formation. So what we shall be seeing is the experimental setup of Michelsons Interferometer, how it works and how the fringe formation happens. So let us go into the discussion for Michelsons Interferometer. So what do we have here is the experimental setup for Michelsons Interferometer. So we will have a light source, right? And you will have light going from it. Your books or textbooks will also discuss about a collimating lens. So let us say this light beam passes through this collimating lens and it is incident on an inclined glass plate. I have an inclined glass plate here, and this inclined glass plate is partially reflecting and partially refracting. Okay, so this inclined glass plate we have here would be partially reflecting and partially refracting. So when I say this is partially reflecting and partially refracting, the beam that is incident here will be reflected, will also be refracted. So in this experimental setup, I have a mirror M1 here, this M1. So this M1 to indicate, I draw this to indicate that M1 is movable. This mirror M1 is movable, and I have another mirror here which I call as M2, right? This is fixed. So I have the eyepiece here. Okay. So now let us see what actually happens to this light. Now this light which is incident on this partially reflecting and partially refracting plate is split into two beams, I told you. One beam goes to, maybe I'll have to shift this mirror. One beam goes to mirror M1, right? One beam would go to mirror M1. This is M1. So this is traveling, this goes to the glass plate, it travels back and goes to mirror M1. Then it is reflected back from M1, passing through this partially reflecting and refracting glass plate. This beam will straight go to the eyepiece. This beam will straight go to the eyepiece. This is the journey of the mirror which goes to M1. So I have another beam which has been refracted. I am so far speaking only about the reflected beam. I have another beam which is refracted. This refracted beam goes to the mirror M2. Refractive mirror goes to the mirror M2, right? And it is reflected back from M2. Then it reaches this glass plate. Again, it is reflected back and it goes to the eyepiece. This is the basic setup. Okay. Now let us analyze this M1 fellow again. Now this beam which is coming from the light source goes to this glass plate, and now I am giving it a name. I'll call it G1. Goes to this glass plate, goes to the end of the glass plate, gets reflected back, goes to M1, comes back, okay, again goes through this glass plate and again goes through this glass plate and straight goes to the eyepiece. Okay. Now look at this. So it has traveled thrice through this glass plate. Once it has come from here, then it is reflected back. Then the beam which is reflected back from here also travels through this glass plate. Thrice it travels through it. But look at the refracted beam. It straight goes to mirror M2, comes back, is reflected back, which means the mirror M2 is lacking this. So to make up for this, we are introducing another glass plate G2 here. So this beam goes to M2 through this glass plate 1. So first it passes through this 1, goes through the glass plate G2 twice, goes here, is reflected back, thrice it goes through the glass plates, then it comes here and it is reflected back to the eyepiece. Now if I am standing here near the eyepiece, for me it appears that both the beams come from this source only. It doesn't appear that they come from this side and all that. So how does the image appear to me? This is how the image appears to me. So I seem to have two different sources which give me two different mirror images, M1 and M2. So now you will get interference fringes, and the nature of the fringes depends on the path difference and the angle between these two theta. So, and I have this as the formula for the interference fringes 2d cos theta plus lambda by 2 is equal to n lambda. What is this lambda by 2? This extra path difference is introduced because this beam travels here, comes back and it's reflected a little at this place. So the extra path difference of lambda by 2 is also introduced here in the case of Michelson's interferometer. Finally, we'll see how the fringes are formed. Now there are various possibilities. The first possibility is M1 and M2 overlap so that there is no air film between the two. So I have M1 here, I have M2 here, there is no air film, there is no interference. So what do I get? I get a dark thing, entirely dark. You can shade that. You can shade that yourself. The other possibility is M1 is here and I have M2 here. So now I get a beautiful circular fringe. When I have a perfect air film, I get a beautiful circular fringe. The next possibility is both of them interfering like this. Let's call this M1, M2, and let's call this M1. Then I would get straight fringes like this. The next possibility, last couple of possibilities, both of them incline like this. I'll have M2 here, I'll have M1 here. Then I would get fringe bent to this direction. Finally, I have this way M2 and M1, and I would have fringe bent to this direction. So what would you require here? You would require this diagram, ray diagram. You would require this, and finally you would require this fringe formation. So in the next one, we'll see another topic. Thank you.